So I'm doing a talk on deploying your JavaScript app in 2018. And it's going to be a fast talk. It's going to be full of brand new technology that maybe you've read about and you've been interested in playing with, but you don't actually know what it's like, performance gains you can get on a real site. And we're going to be looking at a whole bunch of stuff. Just to give you a quick idea of who I am, I build digital products. I started doing Windows NT 4 and Linux in about 1997, and 21 years later, I've done everything from being man pages and the sudo-as file of your Linux distribution to build large-scale AWS API deployment tools. We want it to be secure, otherwise browsers are going to start tearing us apart in 3 weeks. And we want it to be available, i.e. we want to be able to take things down and bring them back up again without anyone noticing. We want to be able to handle getting on Product Hunt, thanks Rado, and handling all that traffic as it comes in. So yeah, we're going to have a look at some new technologies to help your JavaScript app, your JavaScript front end, maybe your Node backend. I'm a Node person, so my examples tend to be Node, but a lot of this technology works across different things. So all these things are small, they're simple, and they're effective. So let's start with the crunchy stuff. Speed. You want HTTP 2. Just by upgrading your HA proxy, your Nginx, your cloud load balancer to HTTP 2, you will see performance gains out of the box. The front page of my blog is a very image-heavy site. It gets a lot of traffic from sites like Hacker News, etc. It's a popular site, but if you can imagine something like The Verge, which every image has a giant, it's very image-heavy layout. The average loading time for that, since moving merely from HTTP 1 to HTTP 2, I'm not sure if you can see it from back there, that's 1.9 seconds to 600 milliseconds. Yeah, HTTP 2 now works in every major browser. I think Safari was the last one to come on board, as Apple kind of always is, but it's there right now. HA Proxy 1.8 came out this year, has HTTP 2 support. Nginx has had it for years now. DigitalOcean's load balancers got upgraded this month for HTTP 2, and this is basically free speed. There is no reason you don't want HTTP 2. In addition to that, you have link preloading, which means when someone requests a page on your site, you can add an HTTP to tell them every other resource they need to load the page. This is sometimes called HTTP 2 server push. I don't really like the word server push because it kind of makes people think of real-time and SSE and WebSockets, and it's a totally different technology. Really, it's just link preloading. But even without link preloading, that's a massive 3x speed increase on a single image-heavy page. Why? Because in HTTP 1, you had 8 connections that can go in parallel. With HTTP 2, it's a single connection that can download a very, very large amount of resources at the same time. So every single image on that page was being pulled down at the same time. And you can see this in Chrome DevTools. HTTP 2, by the way, shows up as Protocol H2. H2 is a word that cool people use to describe HTTP 2. Second thing is Brotli. If you know gzip, you can now meet its new friend Brotli. Brotli is a compression algorithm designed for plain text documents. So obviously things like images and video are already compressed in their own specific formats. Brotli is for CSS, JavaScript, and HTML. I'm trying to remember where this stats came from, but I think it was like top 500 websites, they scraped like the Alexa top 500. And JavaScript on an average is 14% smaller. HTML on average is 21% smaller when using Brotli other than when using gzip. Same thing here. As of 2018, every major browser, so that's Chrome, Firefox, Safari, all support Brotli. There is no reason you don't want to use this. There is one small thing that people often screw up with Brotli. And a lot of blog posts that you read about this will say this. They'll say, Brotli is really good for compressing static files. So you've got a CSS file. You go and make a css.br, and Nginx will send that to the client, the web browser that supports Brotli, and it will be nice and fast. But they say things like, don't use Brotli for dynamically generated files because it compresses more, but it's too slow. Brotli's default setting, so Brotli's default setting is maximum super crunchy crazy compression, and it's really, really slow, but that's the default setting. You can change the default setting. I'm just going to hold the microphone to my face so it doesn't cut in and out anymore. So yeah, you can change that default setting. If you take it down from 9, the default, back to 4 or 5, which is what Akamai and Cloudflare use, you can happily use Brotli on any dynamic content you want, and it will be faster than gzip and still give you better compression. So this is, again, a real-world site. This is a really large JavaScript bundle. It's 1.1 megabyte. It's the front page of Cert Simple. We do cool things with PKI and web crypto. Web crypto is built into the browser, but things like PKI and ASN1 and all these ancient old man data formats are not. So we have JavaScript versions of that, which is why it's 1.1 meg. Like we're actually doing that space. gzip, 242K, about a 20% improvement with Brotli immediately. Just out of the box, content including BR, which is the replacement for gzip. And yeah, 20% speed increase on your static resources, on your text resources, your HTML, your JavaScript, and your CSS. Keeping things small. So obviously, yes, we can download things faster, like Brotli compression and HTTP2. But the only thing that's better than downloading something faster is not actually downloading it. So there's a couple of things that you should be doing. And this is actually, again, an example on our own site. So who here uses NPM? Yeah, cool. So like pretty much the whole of the front row, that table, and everyone who's not shy is using NPM. And there's probably a couple of people who are using like Bower and other bits and pieces. NPM is amazing. And it's not just for things that are for front-end JavaScript. There's also Node stuff. There's also things that are usable everywhere. For example, there's a package called country data, which is basically a massive JSON set of countries, the currencies, the languages spoken, whether they're members of Schengen, and all this kind of stuff that's really useful when internationalizing your website. You can use it on your back end, you can use it on your front end, you can use it on both. There's things to handle pricing and discounts and showing, subtotals, etc. when doing commerce. You can use those back end, front end, or both. So in our case, we did actually use that country data package, because when you visit our site from the Ukraine, it says, hey, yeah, we do stuff in the Ukraine, and we get our information from the Ukraine Ministry of Justice, etc. There's a lot of, we do geo IP, and then we parts of the site to be relevant to customers. However, when we found that when we analyzed our bundle, which was made with Browserify, 230-something K, 320K. 320K of our JavaScript bundle was from one NPM package, which was country data. It's a really useful package, but it's got so much information in there. It's basically like the world fact book turned into JSON. So useful, but massive. Thing is, there are great tools like Discify or Webpack Visualizer to find which packages are using most of your bundle. And in our case, great, 300K, cool. Spent 10 minutes writing a very small script to extract just the stuff we used out of the country data package, use that package instead, and bang, we get an extra 300K. So for Webpack, there's Webpack Visualizer. It looks like that. For Browserify and CommonJS and NPM, there's Discify, which does the same thing. If you use ES6 modules, and I've just used ES6 modules on a recent project, and it actually wasn't a pretty good experience because there's nothing comparable to NPM for ES6 yet. So it was a basic process of rewriting everything to be ES6 modules without a good source of being able to just download arbitrary things and have them be in ES6 module format. So I don't know that many people on big projects using ES6 modules right now because you literally have more than 1 million packages on NPM right now. Sure, they're just going to play with the microphone. Yeah, further away. Okay, can you hear me? Is this on? Okay, cool, excellent. So yeah, if you're using ES6 modules, then yeah, you can use tree shaking, which will actually remove parts of the modules that you're not actually importing into your project for additional gains. So sorting out your bundles handles your dynamic content, your actual web app, but for static pages, what do you do? Probably the easiest thing you can do right now is, I can understand there might be reasons why you might not want to do this, is use AMP. AMP is annoying right now because all your content appears to come from the domain amp.google.com, which a lot of people, including me, hate. This is apparently going to change this year. So Malta, who runs JSConf.eu and also is one of the main guys behind AMP, mentioned they're going to be using a preloading technology in your browsers to show AMP content, even though it's hosted on Google's domain as from your original site, with some kind of checks and balances to make sure that that's actually the content. So AMP is accelerated mobile pages, if you don't know it. It's with AMP, the only JavaScript that's allowed on the site is AMP itself and various plugins for things like analytics, etc. It makes sure the entire page loads in a single request. It consolidates DOM changes, so rather than performing each one of those manually, it calculates the result and then applies the result. Get an ECC P256 certificate. Drawbacks here. Doesn't work on macOS 10.9. Apple says it does, but there's a whole bunch of bugs in the macOS 10.9 implementation. Doesn't work on Windows XP, Android 2.3, and Java 6. This isn't a big deal because if you're running macOS 10.9, you already don't have access to every website using Cloudflare because Cloudflare uses ECC. In future, there's going to be more types of ECC you can pick from. There's a guy called Dan Bernstein who's like crypto Jesus. Everybody loves him. His website is cr.yp.to, which is like the coolest domain ever. Dan Bernstein has a couple of new curves which are more resilient to potential attacks on ECC. OpenSSL just added them. They're going to be approved by certificate authorities to start issuing certificates for real soon. And they give you a couple of different bit lengths to play with as well, rather than just 256. So curve 228, for example, might be really nice on mobile device. It's actually about the same strength as what we've got now, but more efficient on things like mobile battery life. So yeah, if you don't care about this, just get an RA20448 certificate and know that if someone comes along with Windows XP, that will be fine. If you're into crypto, get a P256. That's an ECC curve. It looks vaguely like a hair follicle. The other two curves actually don't look like a hair follicle. They look like kind of like a butthole, but yeah. Content security policy. So every framework has a thing built into it to prevent cross-site scripting. If I visit your website and I'll be like, hey, my name's Mike, open script, alert 1, close script, your Express, your whatever is going to have something to probably implemented inside the templating language, something to escape users trying to inject any kind of active content like script tags and other things into it. However, there's a random paste in the middle of my slide. I don't know where that came from, but most of these don't actually work. Well, they don't work comprehensively. there's about 400 different ways to inject content into a site. Some of them don't handle new lines. Some of them have, you can use a Unicode version of some character that gets translated back into another character and then ends up becoming the slash in com, my cool script, whatever, harvestcreditcards.js. Then your content security policy will say something like, no, scripts is mysite.com, not alexi'scoolhackingsite.com, and the browser will refuse to run any JavaScript that's not from your domain. Thing with content security policy, and again, this is talking about real implementations, is that maintaining that big list of all those domains, all the different places you get images from, all the different places you get fonts from, because fonts can be executable too, sadly. Maintaining that big list for, all right, you've got Untitled Chat, and you're maybe using React, maybe you're using, you've got some inbuilt tweets from happy customers on your site. Maintaining that big list and actually doing the research to find out, okay, what domains do embedded tweets use? What domains does Stripe payments use? That can actually take a little bit of time. So there's a module called CSP by API, which is a JavaScript tool where you say, I'm using OLARC, I'm using Stripe, I'm using Google Analytics, build me a content security policy, and then on top you can add whatever domains you need for your own content. So that'll save you a bunch of research and just make it easier to add and remove things while you add different services on your sites without having to maintain a huge list of domains yourself. So, how do we keep our site up? How do we handle a massive influx of traffic? How do we upgrade our software without anyone noticing? How do we keep our site available? The best thing right now is to go serverless. If you, rather than think about what load balancer you want to use or how you scale your Linux boxes, let's not have load balancers. Let's have Linux boxes. There's Zeit, AWS Lambda, Azure Functions, all these things. You just push a function into the cloud. If 1 million people come along from Product Hunt or Hacker News or whatever, it's fine. Your function is just being run on more boxes. And all these services just take your function and you get charged per function execution and run it on, as much hardware as you need at the time. You don't scale to a particular number. It just does the scaling for you. Yeah, you don't even have to think about scaling up and scaling down because maybe you get a surge, but you don't want all that unused compute power. With serverless, you never have to, you just pay for the extra function invocations used during the surge. So there's a site which is actually hugely popular. It's made by a whole bunch of Node people. I think it's Guillermo Rauch, if I remember correctly. But there's other ones as well. And there's, yeah, it's an exciting time. We're not all in the serverless world right now, so if you're not doing serverless, you'll need a load balancer to sit there and distribute your traffic between your Linux boxes, and I'm presuming it's probably Linux boxes. Maybe it's Windows, maybe it's OpenBSD, but it's probably going to be Linux. All cloud providers provide a load balancer. If you're not sure or you don't want to spend time thinking about it, you can use your cloud provider's load balancer. Don't support ECC certs. DigitalOcean's load balancer doesn't yet. So I want things like Brotli, I want things like HTTP2, I want things like ECC certs. So one of the few places that really gives me all those things is my own load balancer. Other than that, you have HAProxy or Nginx. HAProxy has just added HTTP2 support. Nginx, which is from over there. Basically, they're roughly equivalent to each other. The only thing with Nginx is that you have to pay an absurd amount of money if you want to control the backends dynamically while the server is running. Whereas HAProxy has a little socket you can send little commands to while it's running to do that. So, yeah, Nginx, you will get less out of the box than you get with HAProxy. Yeah. If you want as well, a link to the resource notes. One of the guys from Nginx actually reviewed an Nginx configuration that we used in one of our guides. So it does all the basics: HTTP2, load balancing, HTML5 server-side advanced for real time, browsers come in. We've got our plain text variants, our HTTP versions, and our www and www versions, all redirecting to a single site with a plain domain and HTTPS. We're distributing load amongst a couple of upstream app servers. We have a separate blog service for static content, and we have a sorry page for if something fails, if all the app servers fail. Don't roll your own Nginx configs. We have a published one. It's maintained on GitHub. It uses includes. So if you want to remove functionality, you can remove. Cool. I'm not using HTML5 SSE. You need that include. It's really lovely. We also have the same thing for HA proxy as well. And they're well published on the internet. They have a need often from the developers of the load balancers themselves. To scale, to build a lot of Linux boxes real quickly, you need something to capture your configuration, and you can actually choose a whole bunch of different things as long as you're capturing that somewhere. So 20 years ago, you had CF Engine, you had Puppet. Now you've got things like Docker files. These are different technologies. One's more focused on config management. Docker files, like I just want to build a box. They're all applicable in different scenarios, but I like Cloud Init because it works everywhere. Someone wants you to do something on AWS, great, Cloud Init works there. DigitalOcean, Azure, Google Compute, everyone does Cloud Init. Cloud Init is kind of like Docker, it's just not specific to Docker. It works on physical boxes, it works on VMs, it works on container instances as well. So Cloud Init is YAML. If you're on the internet or you've used YAML before, you probably hate YAML because it's a weird-ass, ugly config format. We're JavaScript people here. And also there's a whole bunch of things that you probably want to do on every single Linux box that you don't want to do yourself, because we all want to do the same things here. We all want to build a Linux box. We want to install every security update. We want to pull down our application from GitHub, probably using a deploy key, or GitLab using a deploy key. We want a Linux service to start and stop and restart our app and do nice logging for us. We want an admin user that can only log in using an SSH key. We want to disable password logins. What else? All the things you want to do on a Linux box to just run an app, really. Tool called Deploy Node on Linux, which is really good for deploying Node on Linux. You could probably adapt it really easy to do any other server-side language, which does that. It's just a generation tool. All I'm specifying is my organization and app, which is used. The organization is a GitHub organization. The app is the project under the organization. It also becomes the name of the service file that's used to start and stop the software. Where you want to run SSH, because obviously port 22 is, hackers will be sitting there bothering your port 22 all the time. So pick some random cool port, a username, and an SSH key, and it will just build Linux boxes as you need. Never think about building a Linux box. It shouldn't be a big deal. Obviously, you can inspect the Cloud Init this is generating to see like the full list of commands and make sure you trust it. Yeah, it works on every cloud provider. I'll send the notes out to, I guess, Twitter after this. So yeah, we have links to HA proxy configs, Nginx configs, reviewed by the creators of Nginx, Cloud Init generators, the content security policy generator you saw, middleware for Express, just to like poop out AMP pages rather than HTML or JSON. How to compare ECC and RSA key strengths if you're interested in becoming a crypto nerd and want to hear about, it's called a RO, RO. There's some interesting stuff. How attack vectors for different types of certificates. Cert Simple does very fast verification for EV. So if you want to get a verified HTTPS cert and you want it to take an hour, and not a week, from a company that only does verified HTTP certs, we do that. And if you want to see stuff I've built, that's my website, and you can find me on Instagram or like listen to like weird house music I like on SoundCloud if you like to. Thank you very much.